Hello students, in this video we'll see a problem from the Lower Michigan Math Competition that involves the probability of counting the number of repetitions when you roll a die until you hit a 6. So here's the problem. It says that Alice rolls a die, and then keeps rolling the die until she hits a 6. Let x be the number of 1, 2, 3, 4, and 5 that repeats itself in this process, that occurs more than once. Find the expected value of x. Okay, so just to understand the context of the problem, here would be a potential sequence. You could roll a 1, then you could roll a 1, then you could roll a 1, then you could roll a 2, then you could roll a 1, then you could roll a 2, then you could roll a 1, then you could roll a 4, then you could roll a 6, okay? In this case, what would x be? Well, 1's repeated itself. So in this case, x, 1 is repeated itself, and 2 is repeated itself, but 4 is not repeated itself. It's only occurred once in this sequence. So here x would be equal to 2, okay? Great. So that's how this random variable x works. Let's figure out how to find what's the density of x, right? So we need to find the probability density of x. So that's the first part of the problem. Question: what is the probability mass function of x? Okay, let's think about it. So here's the key. The key is to let a1, a2, a3, a4, a5, a6 be the numbers in the order that they occur first, right? Be the numbers in the order they occur first. Okay? In other words, over here would be a 1, a 2, a 4, and then what? Then you'd have a 6. Good. Okay. And let Pi be the probability that Ai occurs more than once. Okay, so the easiest one to compute is P6, right? Let's think about why. What's P6? P6 is the probability that 6 occurs more than once. Okay, that's 0, right? Okay, good. And then what about P5? Okay, so P5, let's think about how we're going to figure out P5. So P5 says that A5 occurs, and then what's the chances that A5 occurs again? So A5 occurs. Then immediately after, A5 occurs for the first time. Either you see A5 or you see A6, right? Occurs next. Okay? Now by symmetry, that means that you can either have 1/2 goes to A5, 1/2 goes to A6, you're done. So now you've just proven that P5 is equal to 1/2, okay? Now think what happens with P4, right? With P4, consider now P4. Okay? Well, then you have A4. A4 occurs. Then immediately after, this fact, then what can happen? You can either have A4 or A5 or A6. Right? That's the order in which they occurred, right? After A4, you can get the A5 or the A6, right? So of course, by symmetry now, it's more likely that you're in what case? You have 3 of these things, and more likely you're going to be in the A4 situation, right? Because those are later on, so it's 2/3 is likely, right? So this implies that P4 is 2/3. Good. Now what about P3? Let's do the same thing by a similar reasoning. So by similar reasoning, what's going to happen over here? Well, with A3, you're going to have A3, and then compared with what? Verse A4, A5, or A6, right? So in that case, what do we have? In this case, we have 3/4 is likely, right? Because over here there's a total of 4, and I get preference to the third one, right? So this is 3/4 is likely. So P3 is 3/4. And of course, then we can see what? This implies that P2 is equal to what? P2 is equal to 5, what? 4/5. And then P1 is equal to 5/6. Okay? Those are the corresponding probabilities. Not necessarily independent, but those are the corresponding probabilities. That doesn't give me the PMF of X, it just tells me the probabilities of certain events happening. So I've decomposed X into a sum of random variables, right? So we've decomposed X into X1 plus X2 plus X3 plus X4 plus X5 plus X6. And we're using the fact that the expectation is linear, so that says the expected value of X is going to be what? It's going to be 5/6 over here, plus 4/5, plus 3/4, plus what? Plus 2/3, plus 2/3, plus 1/2. If you simplify this, it's 3.55. So we've used the classic trick of just taking a random variable X and decomposing it into a larger number, a sum of other random variables, right? And we've found those corresponding probabilities all by the symmetry of the process. Thank you very much.